All right, so for this video, we're going to talk about tables. And tables are one of the most difficult things that we cover in third grade. And the reason they're so difficult is because tables cover all operations. So they could be addition, they could be subtraction, they could be multiplication, or they could be division. Now, so far in class, we've only covered addition and subtraction tables. And the basic approach is the same. And so eventually I will do another video, but the approach will be the same no matter what the operation is. And so that's why when we're learning this right now, I try really hard to get them to follow the steps, even if they see a more elegant solution and they already know the rule. I really try to push them to go ahead and go through the motions, because then it makes it so much easier when they have all these options to go to. They have some strategies to fall back on to see if they can figure out how to make it work. So let's look at this first one. So the first thing that I ask students to do is I ask them to label their input and their output. So this would be our input. I'm going to label that with an I, and this is going to be our output. And this is really important because sometimes a common mistake is students will try to figure out the rule by adding up those two numbers, and that's not going to help you find the rule, because the rule is going to go all the way across. It's going to be the same for every single one of these. So a little analogy that we like to use in third grade is your input is when something goes in, and then of course your output is when it comes out. And so the analogy would be, let's say you have a plate of cookies, and then you eat the cookies, and so the cookies go down into your belly, and then the rule is when they mix with the stomach acid, but then when it comes out of your body, even though it's kind of gross, it comes out as poo. And so that's the output. It comes out of your body. So cookies go in, poo comes out. So input, cookies, output, poo. And the reason that this analogy works so good is because we can see that something is happening in our body that we can't see that makes this change. But then the other reason it's so great is because then you can ask your students, when they try to add those two numbers, you can ask them, hey, why are you trying to mix your cookies and your poo together? That's gross. Why would you do that? And then they get a real big laugh out of it. It's really silly, but it's really memorable. And so even though it's kind of gross, it works really well. It really sticks with the kids. So anyways, we have our input and our output, and we got to figure out our rule. So here's how I like to figure out the rules. So the first thing we look at is we look at the number, and we can see that something is making this go from a small number to a big number. So I know I'm adding something to this to get a bigger number. So I'm going to draw my number line now to try to figure it out. So I know that I am starting at 18. And since I'm going up, I'm going to do a jump going this way. And I know I'm adding something to get to 42. Now, the number line is important because it helps them visualize that they're going up, they're adding, which is important for this. And I'll talk about that more later, making sure to understand that this is actually adding. And so we have our number line to visually represent this, so they can see that, oh, I have to add a question mark to get to 42. And typically, like, that would be really difficult because you'd have to count up quite a bit, and that's not very efficient. Most kids don't have strategies for that. So then I would tell them, well, if you can't add going this way, then you have to subtract going from this direction. So when I subtract, I can see, oh, I can't subtract with a question mark, but I know I can subtract with 18. And I know that seems a little backwards because I just said, oh, we don't know how to add with a question mark to get to 42. But the kids are trained, and they know that if they are subtracting and they are moving in this direction, they know that if there's a question mark in the jump, they can still do 18. They're trained, they know. So if you just remind them about that, you're just reinforcing what we're teaching at school. So we know that we can't add going this way, so we've got to subtract going this direction. So I'm going to go ahead and subtract that now. So I'm going to do 42 minus 18. And I don't have enough ones. Got my ones and my tens labeled. So I'm going to borrow a 10 and move a 10 stick over, and I know there's 10 ones and a 10 sticks, so 10 plus 2 is 12, and 12 minus 8 is going to be 4, and then 3 minus 1 is going to be 2. So I can see that it's 24, so I know I have to add 24. Now, I had to subtract to find 24, but I can see here that my number is going bigger, so I have to add 24 to get to 42. And that's a really important distinction because sometimes there's this misconception that if I subtracted here, I'm going to subtract here, which is why the number line really helps, because it really helps them visualize that you're going from a smaller number to a bigger number, so they don't make that mistake. So now we have what we think could be the rule, which is to add 24 across, but we don't know for sure. So we have to test it. So we're going to try adding 24 to the next number and see if it works. So I have 20, and I'm going to add my 24. And I can see that 0 plus 4 is 4, 2 plus 2 is 4, so I got 44, and it works. And so I always tell the kids, always check more than one. So add 24 to this. So now I'm going to do 22 plus 24. 2 plus 4 is 6, 4 plus 4 is 4, and I got 46. So I know it works. So I know the relationship is to add 24. And so I can see that across the input, the rule is the same. It's to add 24 all the way across. Not to add those two numbers. I'm not adding 42, because if I add 42 to 18, I can't use 42 plus 20 to get 44. It doesn't work. I have to use the same rule all the way across. So it goes in, you do the 24, and then it comes out as this number. All right, so let's do a couple more examples. So here's another one. All right, so in this one, we can see that we have a really big number, 675, and we're going down to 659. So because we know that we start big and we end small, we know something's being lost. So my input, something is happening with my input to make my output smaller. So I know that I have to probably subtract. So let's draw our number line to represent this. So I know this time I'm starting at 675. And I know I'm taking something away to get there, to 659. So I've got this visual representation to help me understand. And since in this way, I can actually go ahead and subtract, because I know I can't subtract the question mark. So I skip it, and I come here, and I know I'm going to subtract that. It works really nicely. So now I'm going to do 675 minus 659. Made the mistake, that should be subtraction. So 6, because I need to borrow, this becomes 15. 15 minus 9 is going to be 6. And then 6 minus 1 is 16. 6 minus 6 is 0. So I know that I am subtracting 16 to get to 659. So now I'm going to test it and see if it works with a few more. So now I'm going to do 724, and I'm going to do that right over here, 724 minus 16. And so I don't have enough, so I'm going to borrow. Turns to 14. 14 minus 6 is 8. 1 minus 1 is 0, and then bring down the 7. So I got 708, which works. So that works. So now I'm going to check it one more time, 16. So now I'm going to do 698 minus 16, and I'm going to have 2 left over. 8 left over, 6, it works. So I know the relationship, which is the rule, is subtract 16. And I know that because I'm going from a big number to a small number, where here it's going from small to big. So to go big, I have to add, but because I'm going from big to small, I know I'm subtracting to get that smaller number. So let's do one more. So I've got this one right here. So I can see that I'm going from 2 to 42. So I know I'm getting bigger. So let me draw my number line. I know I'm probably going to add. And so I'm going to start at 2. And I'm going to add something to get to 42. And so now I'm going to subtract, because I know I can't add going this direction. I don't know how to do 2 plus a question mark to get to 42. I mean, some kids might be able to, and so if that's an option for them, that's great. But for a lot of kids, we haven't really talked about the number sense for this yet, how to do this in our head. So we're going to subtract. And so I know I'm going to start with 42. I'm going to subtract 2. And 2 minus 2 is 0. Bring down my 4. So I know I've got to add 40 to get to 42. And so now I'm going to test it. I'm going to put 40 here with 4. And so I've got 40 plus 4, and I get 44, and it matches. So I'm going to try it one more time. 40 plus 5, and I get 45. So it works. So we know the relationship for this is to add 40. So now I know that my rule, my relationship is to add 40. And so just to summarize this, the way this works is you figure out if you're going to add or subtract, because we haven't learned about multiplying or dividing yet, so this is the only option. You must draw the number line. And even though the number line for some kids might seem unnecessary, it is so important once we get to addition, once we get to multiplication and division. So we're practicing it now. We're getting in the habit, because it's going to make such a big difference when we get ready to do tables with multiplication and division rules. And then we use this to help us to add, if we're going to add or subtract, to figure it out. We do the math, and then we check for the rule. And so I make sure when I'm checking the kids that they drew the number line and they have proven that the rule actually works. So that's all we're going to learn from now. There will be a second part of this video, so stay tuned. When we get to multiplication and division, we'll talk about it then.